Alright, in question 5.5 is given that pxy is the point on the graph of h that is closest to the origin. And then it says calculate the distance OP. So every other distance between the origin and the graph is going to be longer, such as the dotted line I'm drawing here, or here, etc. Okay, so how do we go about this? Well, if we're trying to find the distance OP, we need to find an expression for OP. And given that the distance of OP is minimized because it's the closest to the origin, it means that we can use calculus because this is then a minimum value problem. If we can find the turning point on a function that describes the line segment OP, then we can find at which point that function is minimized so that we can find OP. Okay, so that might sound a bit complicated or a bit far-fetched right now, so let's just go through the steps slowly. So what is OP? It's just a distance. And here on the right-hand side, I've written down the distance formula, but you should know this. It's simply the square root of your 2 points, the difference between your two x values squared plus the difference between your two y values squared. Note also that you can write it, you can square both sides and get an expression for d squared. And that's actually what I'm going to be using because then we don't have to work with the square roots. And if we're working with derivatives, we definitely don't want to complicate things with a square root. Okay, so let's do this in the context of OP. So OP squared then is going to be equal to, I'm going to take P as x2 and origin as x1. So then we'll have x minus 0 squared plus y minus 0 squared. Okay, so this doesn't look too helpful yet because OP squared is now in terms of x and y. But remember, we're given the function in terms of y. Y is equal to 2x minus 3, right? So we can sub in 2x minus 3 to the y here. So we can get x squared plus 2x minus 3 all squared. And if we write this all out, we'll get x squared plus 4x squared minus 12x plus 9. So that's just simplifying the brackets. And then that will give us 5x squared minus 12x plus 9. Okay, so for the line OP to be minimized, OP squared has to be minimum as 2. So the corresponding x value here, where OP squared is minimum, will also give us the corresponding x value for when OP is minimized. Okay, so what does that mean? Well, it means we need to take the derivative of OP squared, set it equal to 0, and then that will give us the x for which the expression for OP squared is minimized. Okay, so d OP squared dx is equal to 10x minus 12. Okay, and we'll set that equal to 0, which means that 10x minus 12 is equal to 0, which means that x is equal to 6 over 5. Cool. So now we've got the x value for which OP squared is minimized. So we can sub back in. That means, therefore, OP squared is minimized. OP squared minimized when x is equal to 6 over 5. Okay, so OP squared, the minimum value of OP squared is then 5 times 6 over 5 squared minus 12, 6 over 5 plus 9, and that gives us 9 over 5. But they want OP, but simply taking the square root on both sides means that OP is then equal to the square root of 9 over 5. And we are done. Alright, so let's just recap what I did. I got OP squared as a form of expression which is useful because when we can find the derivative of that expression, set it equal to 0 to get the minimum turning point, sub that back into the equation that expresses OP squared, and then take the square root of that to find the distance of OP. So this is maybe a bit more of a complicated question, but when you think through the steps and you have a game plan, it becomes quite a nice question to do.